Audio Jungle.
College. We are three members in a group from the same organization. We have designed and developed a system named as robotic wheelchair. The other two members will introduce themselves during the course of the video. The thought which provoked us to develop such a project is the plight of the disabled people. We have used two modes of operation, touchscreen mode and accelerometer, which have eliminated the need of the caretaker. In the touchscreen mode, the user maneuvers the wheelchair by using the touchscreen, but in the case of paralyzed patients, they cannot move their fingers also. For them, we have added the additional feature, that is by accelerometer. In the accelerometer, by the movement of the head, the wheelchair is going to move in the desired movement. The hallmark features of this robotic wheelchair is low cost, high efficient, and easy to maintain.
Hi, I'm Raghuchandra. I'm involved here to explain the block diagram. So we have different blocks here. The first block I'm taking motors left and right. We have used here a high-torque PMDC type side shaft motors of 24 volts and 8 amps current, in which these carry a human weights easily. We have programmed these motors to run in 20 kHz working frequency by using PWM technique. Let us move to the second block, motor drivers. Driving such a big torque and high power motors is difficult job. We have made plenty experiments that had failed to run a big motors. Finally, we have designed a H-bridge mechanism by using IR2101 half bridge. We used here two half bridges IR2101 ICs to construct a full bridge. And to switch between clockwise and anti-clockwise direction of the motor, we have designed a 4 IRFZ44N MOSFETs in H-bridge configuration. These IRFZ44N MOSFETs are 600 volts and 49 amps withstanding capability. The third block is 16:2 LCD. We have used here a 32 character LCD module to show the battery capacity, mode of the operation, that is touchscreen or head movement mode, and the direction of the deed. A fourth block is touchscreen along with the driver. So we have programmed here a 4-wire resistive type touchscreen to control the deed of the wheelchair with zero applied force. The touchscreen provides the X and Y axis analog varying voltage depending on the finger placed on touchscreen. That analog voltage we are feeding to the ADC to convert into digital and proceed to the next action. A fifth block is tilt sensor along with the driver. This mainly consists of ADXL300 accelerometer, which senses the tilt angle of the head. An analog value of the ADXL300 is given to the second microcontroller ATmega8 to encode the data and transmit wirelessly using 433 MHz transmitter to the receiver. Moving to the sixth block, the main block in this is a microcontroller. So here the decision maker of our robotic wheelchair is ATmega16 microcontroller. Coming to the programming code aspect of microcontroller, we prepared embedded code to collect input variations and to control output jobs. Mainly have used here 4 channels of ADC to take variation from touchscreen and I/O to receive head sensor signals wirelessly. In order to control the motors, we have used here pulse width modulation technique is applied to the IR2101 H bridges with 20 kHz waveform generation. The next block is batteries. Here batteries provides the portability of the wheelchair. In this, we use two 12 volts 18 amps lead acid batteries as source to the motors and circuit as well. To charge the batteries, we have designed a battery charger circuit with 555 IC which cuts off the battery at 14.4 volts range and with special protection. Finally, power supply. Power supply is the heart of the circuit to run efficiently. we have designed here a 5 volts and 1 amp DC regulated supply to supply to the circuit, because here we used ICs microcontrollers which belongs to TTL family. My friend Gayatri will proceed to the head movement sensor.
The accelerometer, here we have used this ADXL300. This accelerometer will senses the signal when the user tilts his head. This is of analog signal. This analog signal is fed to the microcontroller. It is of 80 MHz. This is of 8-bit microcontroller. Here we are having ADC on chip. This analog to digital converter will convert this analog signal to digital signal. By using this digital signal, we are writing a program. This Unicode is transformed to the encoder, which is of HT12E. This HTI12 is an encoder. This encodes the signal of this microcontroller, and this signal is transformed to the transmitter, that is of RF 433 MHz. It transmits the signal to the receiver through the antenna at a rate of 433 MHz.
Hello, this is Bharati. Let us watch the video of our project.
We are working on the solar panel to implement in our wheelchair in order to charge the battery and to use more efficiently. So coming to the introduction to the parts used in our project are firstly a mechanical session. Mechanical session mainly consists of a metallic body which is specially equipped with aluminium material. So we have used here a caster wheel mechanism to rotate the wheelchair in 360 degrees. So and we have used here a 5.5 diameter wheel for free rotations. Coming to the motors, so we have used here two motors of 44 volts and 8 amps PMDC type motors, so which can capable of carrying 100 kg torque. To drive the motors, we have implemented two high power MOSFET drivers, so with two IR2101 ICs and 4 IR-Z44N MOSFETs. Coming to the main board explanation, so we have mainly 80 Mega32 microcontroller, so we are going to burn the code in a AVR 18 Mega microcontroller. We have a LCD here, so it shows the direction as well as the battery and a mode of operation. We have two modes to control the lead of the wheelchair. The first mode is touch screen mode. So this touch screen consists of four buttons. So nothing but x-axis and y-axis. We are simulating this with the help of ADC in our program. Switching to the second mode, so mainly it is of head movement sensor. So this head movement sensor ADXL300 senses the tilt angle of the head and it is going to generate the ADC value to the microcontroller. So this microcontroller with the help of a transmitter and encoder, so it sends the signal wirelessly to the receiver part. We are continuing our research to implement head gesture sensor to use our wheelchair in very high-end applications like paralyzed people, where they cannot even move their fingers. We would thank EFY providing us such a wonderful opportunity to explore our ideas globally.